Hi, good afternoon. Oops, too loud. So just a little bit of introduction. My name is Arvind Datta. I'm a Senior Business Development Manager at thyssenkrupp nucera. Today we're going to be talking about enabling green energy transformation at an industrial scale. Um, you know, there's a lot of conversation going on, right? Why to decarbonize? 4 to 5 years ago, we were all talking about why to decarbonize, what's climate change, all those questions. So some of it is answered, some of it is still pending, but there's a consensus. I can see that in the industry. And the question was, how do we decarbonize? Now, some companies are past that as well. The next question is, how fast can we decarbonize? And that's what we're going to talk about a little bit, and what nucera is doing these days. All of this in an effort to leave the planet in a better state for generations to come, right? So what does nucera do? So one of the pathways of green hydrogen or pathways of decarbonization is green hydrogen, and nucera fits right in the middle. We enable green hydrogen by taking the renewable energy and providing it to end users, hydrogen end users. Just a little bit about our company. I think it's important to say where we come from and why we believe scaling is the way to go. thyssenkrupp nucera, when it started off, it was a joint venture partnership between thyssenkrupp and De Nora, 66-34%. As of July 7th of this year, we went IPO, and as a result, this is the new ownership. thyssenkrupp nucera is still the largest majority shareholder, followed by De Nora, and we have a few other companies, and there's some free float there. We stand on two legs, our AWE, our alkaline water electrolysis, and then also the CA, which is our chlor-alkali side of our business, which has been pretty stable over the years. Just to get a feel of what we have been doing over the last few years, we start off our journey with a 2 megawatt unit that we built in Duisburg, and we are using that as our test stand and also for continuous improvement of our cells. That plant has been operating since 2018, and we have proved that we can take on the different loads, and we do all kinds of tests on that test stand. Followed by a 20 megawatt unit for CF Industries, which is going to come online in the next 3 to 4 months in Dallasville, Louisiana, in their plant. And then, of course, we are also working closely with Air Products on the 40 megawatt unit for Arizona, which we started working with them on in last year sometime, and it's going to be delivered pretty soon here and commissioned in the next 4 to 5 months. The other notable ones are, of course, NEOM. We're doing a 2+ gigawatt electrolysis plant through Air Products, again, and then Shell, the 200 megawatts for Port of Rotterdam. And then we have Unigel, which is a total of 240 megawatts that we're working with in Brazil. And then our latest announcement is H2 Green Steel, where we're building a 700 megawatt plus plant for green steel. What this shows is we're really on the way to scaling up our technology. One of the things we see for an efficient plant design is plant production of hydrogen that requires industrial scale hydrogen plant. What we're trying to do here is substitute a lot of the gray hydrogen with green hydrogen. And we believe the way to do that is through economies of scale. One of the subsets of what our colleague in Acceler was talking about. And this also fits well when you scale up to the downstream processes as well in power to X market. A little bit about our technology, where we come from. We have over 600 projects that we have executed so far and installed, 10 gigawatts of capacity and 240,000 cell elements. One of the byproducts, and this is in chlor-alkali, which is brine electrolysis. One of the byproducts is hydrogen. So we've been handling hydrogen for over 60 years. And that is the building block for our AWE technology, right? So you'll see the next picture here. It's the exact same modules here, that you will see that we have converted into to AWE. The differences being the feed, which is brine in this case, water in our case with AWE. Arrangements, yes, but the anode that we had to change out to take that feed. Otherwise, it's the exact same block. We took that business where we went from a project business, where we were building all the balance of plant and all the works around it, engineering it, to a product business. That's what we're trying to do. That's how we're trying to scale up alkaline water electrolysis. 20 megawatt modules, standardized as much as we can, with the goal of having a serial production. Being a key technology provider in this market, we're also looking at reducing the complexity of those units. So by standardization, we're doing two things, reducing costs as well as the complexity of it. So you'll get pretty much the same unit. Of course, we'll build it to local codes and standards. The unit is now called Scalum, which is a registered name. It represents speed and scale. That is really what we're focusing on these days. Speed not just in building or manufacturing these units, but also in installation at site in order to reduce your CapEx and OpEx. That's one of our units. It produces about 4,000 normal metric cube per hour of hydrogen, about 8.62 tons per day. We have our stack consists of what we call racks, 4 racks. Each of those 4 racks holds 74 cells, 74 single element cells to be precise, and I'll explain that in a little bit. And total of 296 cells in our electrolyzer stack, and it also comes with a gas treatment module and also the electrolyte circulation module. The single elements are individually monitored, so that represents a big advantage in your OpEx. So that way, if a unit goes down or if a unit is bad because we're measuring it individually, you're able to tell which cell that is and replace that very cell, only that cell. So that's one of the greatest advantages of having the single element technology. We're a non-pressurized design. We believe that the units pressurized outside the electrolyzer is the best way to do it, a safer way to do it. That's why safety is on top of it, and we know that because we've been handling hydrogen for years, and that's one of our message for the market is that safety is the most important thing when it comes to an electrolyzer unit. Like I mentioned, single element unit. This is the way we scale up. Single element unit. Single element goes into a 20 megawatt unit, several single elements, and that 20 megawatt unit scales up into gigawatt scale plants, as you have seen. That coupled with our plans for the future, currently we have about 1.5 gigawatts in cell manufacturing capacity. We have close to 3 gigawatts in module yard capacity, and our goal is to scale it up to 5 gigawatts. So with the scaling up of the gigawatt plant and our standardized design and the way we scale it up, that's how we plan to scale up our supply of these units. So in short, to summarize, AWE technology is here today. It's a mature technology, and you can see by the number of projects that we are executing right now and people do believe in it. And we think there are all kinds of technology that are required for this H2 economy, right? To enable it. AWE is definitely leading the way in scaling it up. And with that, I'll be happy to answer any of your questions outside this room or at our stand at 8:20. Right? Thank you.